On October 29th, 2025, right at Perihelion, the interstellar object 3I/ATLAS didn't just brighten like every comet before it. It exploded. NASA's solar observatories caught the outburst live, and what followed shocked their entire team. The data showed something no comet should ever do: patterns that defy physics and maybe common sense. What exactly did NASA see next, and why are scientists still silent? Let's dive right in. The first burst of data came in quietly, almost too quietly for something this extraordinary. At 5:17 UTC, October 29th, 2025, NASA's monitoring systems lit up. 3I/ATLAS, a frozen traveler from another star system, had just reached its closest point to the Sun. But instead of glowing brighter in a smooth, predictable curve like every comet before it, the brightness graph spiked. Sharp, violent, sudden. At first, engineers thought the sensors were malfunctioning. Maybe solar interference, maybe a calibration glitch. But when confirmation came from multiple observatories in Korea, Chile, and even NASA's own GOES-19 satellite, everyone realized it wasn't an error. Something real had just happened, and it didn't make sense. The object hadn't simply brightened, it had erupted. In astronomy, that's not a word used lightly. It means energy release, gas, vapor, molecules, violently escaping from beneath the surface. But when the first coronagraph images came in, astronomers froze. There was no dust, no shimmering tail, no spray of debris trailing into the void. Just a stretched, bluish glow, a shape that shouldn't exist near the sun. For decades, comets have followed the same laws. As they heat up, they redden. Dust scatters blue light, leaving a warm orange halo. But this time, the pattern reversed. 3I/ATLAS turned blue. Bluer than the sun itself. Spectral analysis confirmed it wasn't a camera illusion. The light carried the chemical signatures of carbon molecules, C2, and amidogen compounds, NH2, known indicators of ice sublimation. That part fit, but the rate didn't. In just 2 weeks, the object began ejecting 5.7 times 10 to the 28th water molecules per second, nearly 40 times more than it had a month earlier. Imagine the surface of a small moon suddenly turning into a high-pressure geyser. That's what scientists were seeing. The problem wasn't the data, it was the timing. Every model of comet behavior said this should have happened gradually, long before the object reached perihelion. Instead, the outburst began exactly at the point of closest approach, down to the hour. Nature rarely works with that kind of precision. That's when the debates began. Some argued that a layer of frozen carbon dioxide on the surface had acted as a shield, delaying the normal release of water vapor. Once that CO2 evaporated, the layer collapsed and sunlight slammed into raw ice underneath, triggering a runaway explosion of activity. It was an elegant explanation, but not a satisfying one, because if that theory were right, we'd see dust. Yet there was none. That mystery drew the attention of the James Webb Space Telescope. Its powerful infrared sensors revealed what might be the key to the entire phenomenon. The surface of 3I/ATLAS wasn't natural anymore. After billions of years drifting through the galaxy, its outer layers had been altered by cosmic rays, high-energy particles that slice through ice, rock, and molecules, rearranging their structure at the atomic level. According to Dr. Roma Maiolo and his team at the Royal Belgian Institute for Space Astronomy, radiation had penetrated nearly 20 meters into the nucleus, creating a dense, chemically mutated crust, a kind of cosmic armor. That crust was unlike anything we've seen before. It wasn't pristine ice from another star system. It was a product of deep time and cosmic punishment, a skin forged by radiation itself. And that changed everything. Scientists had long hoped that interstellar visitors like 3I/ATLAS could serve as time capsules, giving us raw material from distant suns. But this discovery shattered that hope. The outer shell we were seeing wasn't a window into another world. It was a wall hardened by ages of cosmic weathering. Dr. Maggiolo described it simply. 3I/ATLAS is not the same object that left its home system. It's what interstellar space made of it. If that's true, then what lies beneath that crust, the untouched heart of the object, might still hold the original chemistry of a completely different star. But there's no way to drill into something moving 130,000 miles per hour through space. All we can do is watch. As the object moved past the sun, astronomers noticed something else. Something that raised more questions than answers. Its trajectory was almost perfectly straight, far smoother than expected for an object influenced by solar gravity. It didn't wobble. It didn't drift. It just moved, cleanly, steadily, as if it were being guided by something invisible. That caught the attention of Avi Loeb, the Harvard astrophysicist known for his controversial stance on Oumuamua years earlier. Loeb officially requested NASA to release all observational data, including readings from the Mars rovers, which had a unique view of the comet from the Martian horizon. NASA confirmed the rovers had captured optical and magnetometer data, but none of it has been made public yet. Why the secrecy? The official reason: ongoing verification. The unofficial one: speculation that some readings may not fit any current model of natural comet activity. Loeb's message was clear. When something behaves outside every model we know, the last thing science should do is hide the data. And he's right, because what followed made the mystery deeper still. After perihelion, instead of fading, 3I/ATLAS's brightness fluctuated, small rhythmic pulses that repeated at intervals no one could explain. Too slow for rotation, too consistent for random outgassing. Even stranger, the magnetic field data from the Solar and Heliospheric Observatory showed faint symmetrical distortions in the plasma surrounding it, patterns that mirrored each other like ripples from an ordered system. Was this structure coincidence or something else entirely? No one wanted to say the word designed, but everyone was thinking it. Still, the scientific process demands restraint. Maybe the symmetry was the result of layered outgassing through fissures. Maybe the rhythm was caused by thermal cracking cycles. Maybe. But maybe isn't the same as understood. And as Loeb reminded the scientific community, dismissing anomalies doesn't make them disappear. There's another possibility, one that's strangely poetic. Some astrophysicists, like Dr. Suzanne Falsner, believe interstellar objects like 3I/ATLAS aren't accidents. They might be the seeds of planets, the original building blocks flung into space when young stars form. Her simulations show that stars can capture millions of such wanderers as they sweep through the galaxy. These large, icy bodies then attract dust and gas around them, growing into planets. It's an elegant solution to one of astronomy's oldest puzzles. How do rocks smaller than a car turn into planets the size of Earth? But 3I/ATLAS never found a home. It drifted alone for billions of years, older than our sun, older than the Earth beneath our feet, carrying within it the chemistry of a vanished star. So maybe what exploded at perihelion wasn't destruction. Maybe it was memory, a brief, violent reminder of what this object once was. Right now, NASA's instruments are still tracking it, though it's fading fast. If solar heating peeled back even a fraction of that radiation crust, the James Webb Telescope might soon detect signatures of elements never before seen, pure fingerprints of another solar system. Or maybe we'll find that even the core has been rewritten by time, transformed into something entirely alien. Whatever the truth, one thing is certain. 3I/ATLAS has forced us to confront how little we understand about the universe beyond our borders. Because this wasn't just a comet exploding near the sun, it was a story billions of years in the making, a fragment of another world passing through ours, behaving in ways that challenge the very physics we rely on. And maybe that's why this moment matters so much. It reminds us that discovery isn't about answers. It's about questions bold enough to change the way we see everything. So here we are. The interstellar traveler that defied physics is now fading into the dark. But what it left behind isn't just data. It's doubt. It's wonder. It's a challenge to everything we thought we knew about what moves through our skies. Was 3I/ATLAS a natural relic of another world, or something built to endure eternity? The truth may surface in NASA's next release, or in what they don't release. Either way, this is just the beginning. Because if one object like this exists, how many more are out there, waiting to be found? If you want to follow every discovery, every twist in this unfolding cosmic mystery, hit like, drop your thoughts below, and subscribe to Galactic Breaking News. Turn on notifications so you don't miss the next breakthrough that might change how we see the universe. Forever. When 3I/ATLAS passed the sun on October 29th, something impossible happened. Instead of fading like every known comet, it brightened, turned electric blue, hotter than our own star, and began accelerating without losing mass. Telescopes worldwide captured the anomaly, and now even Harvard scientists are stunned. 9 unexplained phenomena, and a question no one can ignore. Is ATLAS natural or engineered? Let's dive right in. When 3I/ATLAS swung past the sun on October 29th, astronomers expected to watch another frozen traveler melting away under solar heat. But instead, the universe decided to remind us that it still has secrets far beyond our comprehension. What unfolded wasn't a simple outburst, it was a contradiction of physics itself. Instead of fading, ATLAS brightened. Instead of reddening, it turned an electric blue, hotter than our own star. And instead of slowing down, it accelerated, veering slightly off course in a way that left scientists at Harvard's Center for Astrophysics stunned. At first, the team thought it might be a miscalculation, but the data didn't lie. The ALMA Observatory in Chile, one of the most precise instruments on Earth, confirmed that Atlas was drifting about 4 arcseconds from its expected position. That's not a glitch, that's thousands of kilometers off. Something was pushing it. But what? In space, there are only a few known forces that can move an object that way: radiation pressure, gas jets, or gravitational interactions. But none of them fit. There was no gas, no dust, no debris trail. By every model we have, the object should have been shedding billions of tons of material, and it wasn't. If that's true, then we're looking at an object that can accelerate without losing mass. That's the kind of sentence that makes scientists uncomfortable, because it shouldn't be possible. And that's when Avi Loeb entered the conversation. Loeb,